Hello again, and welcome. I'm glad you're here. Maybe your day was long, or maybe it only felt that way, stretched thin across hours that seemed heavier than usual. Either way, all of that is behind you now. Nothing is being asked of you. You don't have to solve anything, fix anything, or even stay awake. This is your moment to let go. Let your breath grow slower, gentler. Let your thoughts rise and drift away like mist in the night. Tonight, instead of counting sheep, we'll wander towards something far stranger, far deeper. Not to the stars themselves, but to the places where stars collapse and vanish. To the quiet boundaries where time bends and light itself cannot escape. Tonight, we're drifting toward black holes. But don't worry, this is not a journey into fear. Black holes are not monsters. They are mysteries, resting silently in the fabric of space, patient and profound. Think of them as the universe's deepest lullabies, humming in the background of existence. With each fact we uncover, we'll float a little closer, carried inward by curiosity, not falling but gliding, safe, calm, and unhurried. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or left a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Black holes are not like anything else in the universe. They are places where gravity is so strong that not even light, the fastest traveler we know, can escape. A black hole is not a thing in the way a planet or a star is. It is more like a boundary in space, a region where the rules bend until they break, and time and matter collapse into silence. At first, this idea may sound frightening, like falling forever into the dark. But here, together, we'll treat it differently. Tonight, black holes are not terrors, they are wonders. They are the universe's deepest secrets, resting quietly in the fabric of space, and we will approach them gently, like stargazers at the edge of a cosmic ocean. Imagine closing your eyes and floating weightless. You are drifting, not downward, not upward, but inward toward a place beyond sight. The stars are behind you, their light falling away, and ahead there is only a hush, a quiet, deeper than silence. That is the essence of a black hole. It is not an object waiting to swallow you. It is a mystery that calls us closer, an idea that reshapes everything we thought we knew about matter, space, and time. Tonight, you are not falling into danger. You are gliding into curiosity, resting as you travel, letting wonder carry you instead of fear. When scientists first imagined black holes, they weren't even sure such things could exist. They were born out of equations, strange solutions that suggested a mass so dense its pull would be infinite. For a long time, they were only theory, whispers written in mathematics. But now we know they are real. They lurk at the centers of galaxies. They hide in the ashes of stars. They bend the light of entire constellations and ripple space itself with their presence. And yet, for all their power, they are still invisible. You cannot point a telescope and see one directly. You can only see their influence. The way nearby stars dance, the way radiation flares as matter falls inward, the way space quivers when two of them collide. That is what makes them so enchanting. Black holes are the unseen giants, the shadows behind the stage, the silence between notes in a symphony. As you listen tonight, you don't need to keep track of every detail. Let the images wash over you, like gentle waves lapping against the edges of thought. Imagine black holes as cosmic caves, gateways into gravity's heart. Imagine them as silent anchors, keeping galaxies from flying apart. Imagine them as the universe's memory keepers, carrying within their depths the stories of stars that lived, burned, and collapsed. Each fact we'll share about them is a small light, not one that dispels their darkness, but one that outlines their shape, helps us glimpse what cannot be seen. Over the coming chapters, you'll hear 100 truths about black holes. Some will be simple, others will stretch the imagination. All of them are pieces of a larger mystery, a picture still unfinished. It helps to think of black holes not as endings, but as transformations. When a star collapses and leaves a black hole behind, nothing is wasted. The light that once burned in that star has traveled outward across space, perhaps still traveling now, falling softly into some distant world's night sky. What remains is not destruction, but change. The mass is still there, just compressed beyond comprehension. In a way, a black hole is not absence, but presence at its most intense. It is matter pressed so tightly that it folds the fabric of reality itself. As you settle deeper into your pillow, imagine the fabric of space around you stretching and bending. Imagine that if you pressed your hand against the air, you could feel the universe's weight, a quiet, elastic web that holds you, the earth, the stars, everything. Now imagine that web drawn so tight in one place that it sinks without end, like a well with no bottom. That is the essence of a black hole. It is the universe saying, here, the rules are different. Here, time itself slows to a whisper. When you think of black holes, you don't need to picture violence. Think instead of stillness. From the outside, they are perfectly silent. No light escapes, no sound travels. If you orbited one at a safe distance, you would feel its pull just as you would feel the pull of any star or planet. You could drift around it for eternity, calm and unhurried, circling a horizon you could never cross. In that way, black holes are not only mysteries of physics, but also reminders of patience, of the parts of the universe that will not give up their secrets quickly. You might wonder why we seek them out at all. Why study something that hides itself so completely? The answer lies in what black holes reveal about us. To understand them is to test the very limits of knowledge. They show us how far gravity can go, how space and time behave when pushed to extremes. They remind us that the universe is not only vast, but strange, more surprising than even our boldest imaginations. And perhaps most importantly, they remind us of humility. No matter how much we learn, there are still places where the answers fall inward, where our understanding stretches thin, where silence swallows certainty. So tonight, as you rest, let black holes be companions to your dreams. Let them drift at the edge of your thoughts, not as threats, but as wonders. Picture their horizons as gentle borders, their darkness as a canvas on which the universe paints its most delicate mysteries. You are safe here, on Earth, far from any such abyss. And yet, your atoms, the very particles that make you, have been shaped by stars whose deaths may one day end in such forms. You are connected to them, not by distance, but by history. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it came from stars that burned and collapsed. In knowing black holes, you know something about yourself. Over the next chapters, we will travel together through 100 truths about these strange places. We will speak of how they form, how they grow, how they shape galaxies and stir the fabric of reality. We will hear of their births in collapsing stars, their collisions that ripple space, their shadows caught at last by telescopes built to see the unseeable. And through it all, you will be free to drift, to imagine, to rest. Black holes may be the most mysterious objects in the cosmos, but tonight they are here only as quiet guides, leading you into wonder and softly into sleep. When you hear the words black hole, your mind might leap to darkness, danger, or the edge of existence itself. But let's begin slowly, with something simpler. A black hole is not a hole in the way you imagine one in the ground. It is not empty space. It is a region where gravity has grown so strong that escape is impossible. Not for planets, not for light, not for anything. This invisible boundary is called the event horizon, the point of no return. Once something passes through it, there is no way back. The black hole keeps it forever. At the very center, beyond even the event horizon, lies the singularity, a place where all the mass is crushed into a point, where density becomes infinite, and the laws of physics, as we know them, fail. It is tempting to picture the singularity as a kind of object, a dot of unimaginable weight hanging in space, but that's not quite right. A singularity is more like a warning sign in our equations, a place where numbers no longer make sense, where gravity curves so violently that our understanding breaks. And yet, even if we cannot describe it fully, we know it is there because the universe around it behaves as if it must be. Black holes are like shadows of certainty cast by the limits of our knowledge. The simplest way to imagine how a black hole forms is to begin with a star. Not a small star like our sun, but a giant, one many times heavier. For millions of years, this star burns, fusing atoms in its core, creating the light and heat that pour across space. But eventually the fuel runs out, and the star can no longer resist its own weight. It collapses inward, and for a moment, the brilliance is extinguished, like a candle flame flickering and going dark. What is left is not gone but transformed, the star's weight pressed into a smaller and smaller space until a black hole is born. In this way, a black hole is not so much a death as it is a remainder, the heavy core of a star collapsed beyond redemption. That is the first truth. A black hole is not a hole at all, but a region of space where gravity dominates everything. The second truth is that the event horizon is not a surface you could touch. It is a boundary without substance, invisible yet absolute, like a shoreline drawn not in sand but in space-time itself. Cross it, and the path back is sealed. The third truth is that, from a safe distance, a black hole is no more threatening than any other object of the same mass. If the sun were replaced by a black hole of equal weight, Earth would continue its orbit unchanged. We would still circle around as before. It would grow cold and dark without the sun's light, but the gravity itself would feel the same. The fourth truth is that time behaves strangely near a black hole. For you, falling toward it, everything would feel normal. But to someone watching from afar, your fall would seem to slow, stretching into eternity as you approach the event horizon. Clocks tick differently depending on where they are, warped by gravity's pull. A black hole is not only a trap for light, it is a sculptor of time. The fifth truth is that we cannot see them directly. Their darkness hides them perfectly. What we see instead is the glow of matter as it falls inward, heating to incredible temperatures, releasing light, X-rays, and sometimes jets of energy that blast outward across galaxies. In this way, black holes reveal themselves not by what they are, but by what they do to everything around them. And still, for all we know, so much remains only suspicion. We know that black holes bend space and time, but we don't yet know what happens at the singularity. Does matter truly collapse into an infinitely small point? Or is there some other structure hidden beyond our equations, some deeper law we cannot yet see? We know that black holes evaporate slowly over unimaginable times through a process called Hawking radiation, but we have never observed this directly. It exists only in theory, waiting for confirmation. We suspect that black holes hold the keys to unifying the laws of the very large, general relativity, with the laws of the very small, quantum mechanics. But we have not solved that puzzle. Think of them as doors in the dark, half open, inviting us to look closer, but never revealing the whole room inside. They are mysteries disguised as certainties, places where what we know ends and what we do not know begins. To drift near a black hole in thought is to float at the edge of comprehension, looking over the border into a country we cannot yet travel. and yet we are drawn, again and again, to that edge. Imagine yourself floating near an event horizon, far enough to be safe, close enough to see the effects. Around you, stars bend into arcs, their light curving in strange paths, distorted by the invisible pull. If you watched a clock ticking far away, it would seem to race ahead, while your own time felt steady. You might see matter falling toward the horizon, flaring briefly as it spirals inward, like sparks flickering before they vanish into the dark. The whole itself would remain featureless, not glowing, not shining, just an emptiness that pulls the universe inward. Black holes are both simple and complex. Simple, because at their heart, they are nothing more than gravity taken to an extreme. Complex, because the consequences of that simplicity reach into the deepest corners of physics. They are teachers that speak in silence, showing us where our knowledge cracks, daring us to imagine more. They are reminders that the universe is not fully mapped, that beyond the starlight and galaxies lies a frontier of questions without answers. As you rest here tonight, you don't have to wrestle with those questions. You only have to let them drift past, like shadows across the sky. A black hole is a region, a boundary, a singularity. It is a collapsed star, a candle gone out, leaving only weight. It is an event horizon, invisible but final. It is a sculptor of time and a silencer of light. And it is also a promise that the universe still holds mysteries grand enough to humble us. Tonight, that mystery is not a threat, but a lullaby, deep and slow, carrying you into sleep as gently as the pull of gravity itself. The story of the smallest giants begins with fire. Imagine a star many times larger than our sun, burning furiously through its fuel, shining with such intensity that entire systems revolve around its radiance. For millions of years, it glows, its core fusing atoms into heavier and heavier elements, building light from pressure and heat. But there comes a point when even the brightest star cannot resist its own weight. The fusion slows, the balance tips, and the star begins to collapse. In its final act, it erupts outward in a supernova, one of the most violent explosions in the cosmos, scattering light across the galaxy. Yet what remains after the firestorm is not an empty void, but something smaller, darker, and infinitely heavier, a stellar mass black hole. These are the embers of suns that burn too bright, the remnants of lives too heavy to fade quietly. Stellar mass black holes are the most common kind we know, born from the death of massive stars. They usually weigh between 3 and a few dozen times the mass of our sun. Picture that. All the weight of a star collapsed into a sphere, perhaps only a few tens of kilometers across. A city-sized region holding the mass of worlds, a cosmic ember glowing invisibly. The event horizon of such a black hole is small compared to the vastness of galaxies, yet the gravity it commands is absolute. These are not giants in size but in power, quiet anchors scattered through the Milky Way, born from endings that were once dazzling beginnings. The sixth truth about black holes is that stellar mass varieties are created in death. They are the natural outcome of stars at least 20 times heavier than our sun. When the fuel is gone, gravity takes over, pressing the core into collapse. If the core is massive enough, no force in the universe can stop it. The seventh truth is that they come in a range of sizes, but none small by human standards. The lightest known black holes are around 3 solar masses, the heaviest over 100, though those at the extreme edge are rare. The eighth truth is that while small in astronomical terms, their density defies comprehension. Imagine the Earth crushed into a marble. A stellar mass black hole is like the sun compressed into a sphere just a few dozen kilometers wide. We cannot see these black holes directly. They reveal themselves only by what they do to their surroundings. The ninth truth is that many are found through their dance with companion stars. If a black hole orbits near another star, it can siphon gas from its partner. That gas spirals inward, heating up, glowing in X-rays as it falls. Telescopes on Earth and in orbit catch these invisible beams, whispers of the black hole's presence. The 10th truth is that even isolated black holes can betray their existence by how they bend the light of distant stars. As they pass in front, they act as lenses, warping space and magnifying the background. It is as though their invisibility becomes a magnifying glass, bending the fabric of the cosmos itself. Scattered across the galaxy, these small giants number in the millions. Astronomers estimate that in the Milky Way alone, there may be more than 100 million stellar mass black holes, drifting silently, unseen. Most have no companions to feed from, no light to betray their presence. They wander like ghosts through the spiral arms, reminders of stars long gone, their brilliance collapsed into silence. Every one of them once blazed across the night as a sun, perhaps brighter than we can imagine, only to end in collapse and leave behind this quiet remnant. Think of them as sparks left after a fire, except these sparks do not fade. They endure, hidden, carrying the memory of a star that once was. Each one is a fossil of light, a record of cosmic cycles where life and death play out on scales too vast for us to witness in full. And yet, we can feel their weight in equations, see their shadows in data, trace their stories in the trembling of nearby stars. When you picture a stellar mass black hole, you might imagine a dark sphere, but the reality is stranger. From far away, you would see distortions, arcs of light bent into halos, the background stars twisted by gravity. Time itself would run differently near the edge. To the black hole, nothing unusual happens as matter crosses the horizon. But to us, watching from afar, the fall stretches into eternity, a slow, vanishing act played on the stage of space-time. Astronomers have measured some of these black holes with exquisite care. Cygnus X1, one of the first ever detected, lies about 6,000 light-years away. It weighs around 21 times the mass of our Sun and feeds from a massive blue companion star, creating powerful X-ray outbursts. Another, called V404 Cygni, flares with sudden bursts of light as matter crashes inward. Each one is a laboratory of extremes, teaching us how gravity behaves when pushed to its limits. Yet, even as we study them, they remain mysterious. How many are there, unseen and silent? Do all massive stars end this way, or are there hidden thresholds, delicate balances we do not yet understand? Some theories suggest that stellar mass black holes may merge over time, creating heavier ones, even stepping stones toward the supermassive giants at the centers of galaxies. The cosmos builds in layers, one collapse feeding another, one ember adding to the furnace of creation. As you let these thoughts drift, remember that the smallest giants are all around us, though we cannot see them. They are the hidden bones of the galaxy, the relics of stars that lived and died before our world was formed. They are quiet, relentless, and enduring. They do not burn, but they hold the memory of burning. They do not shine, but they bend the paths of light. They are not alive, yet they are reminders of life, for without the heavy elements forged in the explosions that created them, there would be no earth, no oceans, no people to wonder at the night sky. So tonight, as you close your eyes, imagine drifting past one of these stellar mass black holes, the remnant of a star that once outshone entire constellations. Picture the silence, the weight, the gentle bending of starlight around its edge. You are safe here, far from its pull, floating in thought. The ember of a sun waits below, quiet and invisible, but its presence fills the space around it. And in that presence, you feel both the fragility of stars and the permanence of their endings. The smallest giants are not to be feared, but to be remembered, as echoes of brilliance now resting in the dark. In the heart of almost every galaxy lies a weight so profound it defies easy imagination. These are the supermassive black holes, colossal anchors with masses ranging from millions to billions of suns. Unlike their smaller stellar cousins, they are not the remnants of single stars but vast structures woven into the very fabric of galaxies themselves. They sit quietly in the center, invisible, but their influence stretches outward for tens of thousands of light years, shaping the rhythm of stars, the movement of gas, and the destiny of galaxies. It is as though each galaxy carries within it a hidden conductor, guiding the great symphony of cosmic motion with silent gravity. Our own home, the Milky Way, is no exception. At its center, cloaked behind veils of dust and hidden from our naked eyes, lies Sagittarius A. It is a supermassive black hole with more than 4 million times the mass of the Sun, squeezed into a region smaller than the orbit of Mercury. We cannot see it directly, but astronomers have traced its presence by watching nearby stars whip around it at extraordinary speeds. These stars trace invisible loops, completing orbits in mere decades, as though they are dancers circling a dark partner that never shows its face. In the very core of our galaxy, the unseen dictates the motion of the seen, pulling the Milky Way into its patient and inevitable spin. The 11th truth about black holes is that nearly every large galaxy we have studied seems to harbor one of these giants at its core. They are not accidents or outliers, but central features, entwined with the story of galaxy formation itself. The 12th truth is that their mass is often proportional to the galaxy around them. Astronomers have found that the size of the central bulge of stars in a galaxy often matches the heft of its black hole, as though the two grow together, each feeding and shaping the other across billions of years. This relationship suggests they are partners, not just in motion, but in evolution. The 13th truth is that Sagittarius A is mostly quiet today, but there is evidence it was not always so. Traces of radiation, giant bubbles of gamma rays ballooning above and below the galactic plane, hint at a time when our black hole may have blazed as a quasar. During that epoch, it would have devoured matter in torrents, igniting with a brilliance brighter than the galaxy itself. Now it sleeps, pulling quietly, its hunger subdued, though the echoes of its past still glow faintly across the sky. The 14th truth is that other galaxies reveal this past more dramatically. Quasars, some visible from billions of light years away, are the visible outbursts of supermassive black holes in their youth, devouring matter at a furious rate, shining across the universe as cosmic beacons. They remind us that these dark giants are not always silent. The 15th truth is that without these massive hearts, galaxies might not hold together in the way they do. Their gravity anchors the core, their presence sculpts the paths of stars, their feeding and resting cycles regulate the flow of gas and the pace of star formation. They are more than hidden objects. They are central engines, subtle but powerful, determining the character of the galaxies they inhabit. When we imagine a supermassive black hole, it is tempting to think of it as merely a larger version of the smaller kind. But the truth is stranger. While stellar black holes are born from single stars, the origin of these titans remains mysterious. Some theories suggest they formed from the collapse of enormous primordial clouds of gas in the early universe, skipping the step of stars entirely. Others believe they grew from smaller black holes, merging again and again, feeding on matter until they became the giants we see today. Perhaps both are true, different roads leading to the same destination. Whatever their birth, their presence at the center of galaxies tells us they are fundamental to how the cosmos organizes itself. In the Milky Way, Sagittarius A is like a heartbeat too slow for us to hear, yet steady enough to define our home. Every star you see in the night sky, including our sun, is ultimately bound by its pull. We orbit the galactic center once every 200 million years, tracing a slow circle that owes its path to the hidden weight of the black hole and the stars surrounding it. If you could zoom out far enough to see the Milky Way as a whole, you would see a spiral turning gently, all its arms and clusters moving in response to an unseen anchor. That anchor is Sagittarius A. What makes these hearts extraordinary is not only their weight, but their paradoxical nature. They are invisible, yet they give structure to what we see. They consume, yet they also sustain by shaping the galaxies that give rise to stars, planets, and even life. To imagine a galaxy without its central black hole is to imagine a wheel without a hub, a dance without a rhythm. The stars might still shine, but their motion would be scattered, their gathering less ordered. The galaxies we see, luminous and patterned, owe their beauty in part to something that cannot be seen at all. The wonder of Sagittarius A is that it is both terrifying and comforting. Terrifying because of its immense gravity, its absolute event horizon, its finality. Comforting because it has always been there, steady and patient, while life emerged on Earth. While our ancestors first looked up and saw the stars, it has been watching, silently, through the entire history of our species, though we only learned of its existence in the last few decades. That knowledge changes how we see our place in the galaxy. We are not drifting aimlessly, but circling a great unseen heart, part of a vast dance we barely comprehend. If you close your eyes and imagine floating above the galaxy, you might picture the spiral arms curling outward like delicate smoke, stars glowing like embers scattered across darkness. At the center, unseen but undeniable, lies a weight so profound it holds all of it in place. You would not see Sagittarius A, but you would see its influence everywhere, in the paths of stars, in the warping of space, in the quiet rhythm of the galaxy itself. And so, as you rest tonight, know that above you, beyond the reach of your eyes, there is a silent conductor at work. It does not shine, it does not speak, but it shapes everything. The Milky Way is not just a river of stars. It is a dance around an invisible heart. That heart is Sagittarius A, the supermassive presence at the center of our home. A giant, so quiet and so powerful that it has written the very shape of the sky you fall asleep beneath. Between the smallest stellar remnants and the vast titans that anchor galaxies lies a mystery we are only beginning to uncover. These are the intermediate mass black holes, a class so elusive that even their existence has long been debated. They are sometimes called the middle children of the black hole family, neither born from the collapse of a single star nor towering over galaxies with billions of solar masses, but something in between, ranging from a few hundred to perhaps 100,000 times the mass of our Sun. They are the missing links, the bridges that may explain how black holes grow from embers into engines of galaxies. Their story is quiet, tentative, pieced together from subtle evidence scattered through the cosmos, and yet it may hold the key to understanding how the universe built its structures on every scale. The 16th truth is that intermediate mass black holes are rare, or at least rarely found. Astronomers have discovered countless stellar mass black holes in binary systems and confirmed the presence of supermassive black holes at galactic centers, but the middle ground remains thinly populated. If they exist, they are more difficult to detect because they do not blaze as brightly as quasars or reveal themselves as dramatically as stellar companions. They may be hidden in quiet corners of globular clusters or in the faint outskirts of galaxies, their presence betrayed only by the unusual motions of stars or the faintest whispers of radiation. The 17th truth is that globular clusters may be their homes. These are dense, spherical gatherings of stars, some older than galaxies themselves, circling the Milky Way in patient orbits. Packed with hundreds of thousands of suns crammed into relatively small spaces, these clusters are natural laboratories for strange gravitational events. When astronomers studied the way stars move within certain clusters, they noticed unusual accelerations, as if something heavy yet invisible was pulling at them. In some clusters, the evidence points to a central object with hundreds or thousands of solar masses, too massive to be a single star, too small to be a supermassive giant. These hidden centers may be the long-sought intermediate mass black holes, sleeping quietly among ancient stars. The 18th truth is that gravitational waves have begun to uncover their traces. When detectors like LIGO and Virgo capture the ripples in space-time caused by black holes colliding, they sometimes record events that produce final black holes larger than stellar mass, but not nearly large enough to be supermassive. These mergers suggest that black holes can grow step by step, colliding, merging, and climbing the ladder of mass. Each detection adds weight to the idea that intermediate black holes are not just theoretical, but real players in the cosmic story. The 19th truth is that these middle children could be the seeds of the giants. One of the greatest puzzles in astronomy is how supermassive black holes grew so quickly in the early universe. Quasars blazing just 1 billion years after the Big Bang imply black holes with billions of solar masses already in place, too massive to have formed only from the collapse of stars. But if intermediate black holes existed early on, they could have acted as stepping stones, merging with each other and feeding on gas until they reached enormous proportions. They would be like scaffolding, invisible in the final structure but essential for its creation. The 20th truth is that we may be on the verge of finding them in greater numbers. New telescopes and observatories, from the James Webb Space Telescope to next-generation gravitational wave detectors, are extending our reach into the faint and hidden corners of the universe. With their sharper vision, they may uncover more of these middle-mass black holes, confirming their place in the cosmic hierarchy and filling in the gap between the smallest and the largest. If stellar mass black holes are the glowing embers of collapsed suns, and supermassive black holes are the beating hearts of galaxies, then intermediate mass black holes are like the quiet bridges between those states. They are neither as visible as the fires that birth them, nor as obvious as the structures they help to sustain. Instead, they exist in shadows, subtle hints that the universe builds itself, not in leaps, but in layers, each stage paving the way for the next. Imagine a globular cluster, its stars tightly woven together like beads on a cosmic thread. In the very center, something unseen holds sway, its gravity so intense that stars whip past at impossible speeds. You would not see light falling in, for there may be little gas left to feed it, but you would feel its pull in the strange choreography of its neighbors. The cluster moves as if a heavy hand rests at its heart, a quiet presence shaping everything around it. That presence may well be an intermediate black hole, a middle child forgotten by most of the universe, but vital all the same. Their rarity makes them all the more mysterious. Why are they so difficult to find? Are they truly scarce, or are they simply hidden beyond the reach of our instruments? If galaxies are filled with stellar remnants and crowned with giants, surely the steps between must exist. Perhaps they wander the outskirts of galaxies, too faint to notice. Perhaps they are swallowed by larger black holes before they can reveal themselves. Or perhaps they are waiting in plain sight, their signatures disguised as ordinary stellar motions, overlooked until we know better how to read them. The universe often hides its most important truths in silence. The middle children may not roar with energy like quasars, or announce themselves with brilliant X-ray flares. They may whisper instead, in the trembling of starlight, in the faint vibrations of space-time, in the barely perceptible shifts of ancient clusters. Yet those whispers may be enough to tell us how galaxies grew, how order emerged from collapse, and how the universe bridged the gulf between the very small and the unimaginably large. As you drift tonight, picture those clusters floating above the galactic plane, ancient and golden, older than the Milky Way itself. Picture them holding secrets in their centers, hidden wells of gravity that bend the paths of stars without ever showing their faces. Somewhere in those dense hives of light, a middle child may be waiting, quiet, patient, bridging eras and scales. If the stellar black holes are the remnants of fire and the supermassive ones, the architects of galaxies, then these rare intermediates are the unseen scaffolds, holding the cosmos together step by step. They may be few, but their story is vast, stretching across billions of years and countless collisions, reminding us that the universe does not leap to greatness all at once. It builds slowly, layer by layer, even in the dark. The edges of nothing are not sharp or jagged, but soft and absolute, a boundary drawn by gravity itself. This is the event horizon, the invisible threshold that defines a black hole. Beyond it, no light can return, no signal can escape, no story can be told. It is not a surface in the way a planet has a crust, nor a barrier in the way a wall resists you. It is a horizon, a line in space-time that separates the knowable from the unknowable. To stand outside it is to remain in the universe we understand. To pass within is to be cut off forever. The 21st truth is that the event horizon is the defining feature of a black hole. It is the boundary that turns a collapsed star or an accumulation of mass into something more profound. Without an event horizon, there would be only dense stars or compact objects. With it, there is a place where time and space fold so tightly that even light, the fastest traveler in the cosmos, cannot outrun the pull. If you could drift slowly toward a black hole, the horizon would not appear as a wall or a sudden edge. You would see nothing marking the crossing. Instead, from your perspective, you would fall smoothly inward. But to someone watching from far away, your motion would seem to slow as you neared the horizon. This is the 22nd truth. Time behaves strangely at the edge of nothing. To a distant observer, your descent would appear to freeze, your image stretching and dimming, trapped just outside the horizon, fading into redder and redder light until it disappeared. Yet for you, there would be no hesitation. You would cross the boundary in finite time, pulled into a realm that can never send messages back. The event horizon is not just a border in space, it is a border in time. This strange slowing of clocks, this warping of duration, is called time dilation, and it is one of the most uncanny features of relativity. The 23rd truth is that time itself bends near a black hole. Gravity is not merely a force pulling on objects. It is the curvature of space-time itself, and near a black hole, that curvature grows so steep that seconds stretch into eternities. To stand near the event horizon would be to live in a place where the rest of the universe races ahead, where entire epochs might pass in what feels like moments. In this way, black holes are not only prisons of matter and light, but also deep wells of time, distorting the very rhythm of existence. The 24th truth is that nothing can escape once it passes the horizon. The name point of no return is not a metaphor, but a physical law. Light itself, massless and swift, cannot claw its way back once it crosses. Matter, no matter how fast it moves, cannot reverse its fate. Even information, in the strict sense used by physicists, becomes uncertain at this edge, vanishing into debates about what is preserved and what is lost. To approach the horizon is to face an absolute certainty. Once you go past, your future ends at the singularity. The horizon is not a place you can linger. It is a one-way door. And yet, the 25th truth is that from outside, the horizon has a strange kind of serenity. Black holes are not gaping holes in the sky. They do not swallow like mouths. Instead, they appear as perfect spheres of darkness, smooth and quiet, surrounded often by luminous disks of matter spiraling in. They are defined less by violence than by silence. The horizon is invisible, but the shadow it casts is not. We have even taken its picture, a blurry golden ring encircling a void, proof that the edge of nothing can leave a mark upon light itself. To look at that image is to gaze upon a boundary that no eye can ever see directly, a limit painted by the way light bends around an absence. Meditate on what it means to have such an edge. On Earth, horizons are temporary illusions, lines of distance we can always move closer to, always surpass. But the horizon of a black hole is not like that. It is a horizon you can approach but never cross, and still remain in the same world. It stands forever, just beyond reach, guarding mysteries that no traveler will ever return to describe. In a sense, Black holes hold secrets not because they choose to, but because nature itself has written silence into their structure. Imagine drifting toward such a place, not in terror but in curiosity. You would see stars bend into arcs around you, their light pulled into strange distortions as it tried to flee. The closer you came, the more the universe behind you would speed up, racing through years and centuries in your sight. And then, quietly, without spectacle, you would pass through the edge of nothing. No alarm would sound, no wall would greet you, but you would no longer belong to the universe you left. The horizon is the most final of all thresholds, a doorway that only swings one way. Black holes remind us that not all mysteries can be crossed. Some are meant to remain at the edge of our vision, teasing us with hints but never surrendering their full truth. The event horizon is both a boundary of physics and a symbol of human longing, the limit of what we can know, drawn not by our ignorance, but by the fabric of reality itself. To contemplate it is to stand at the shore of a vast ocean of silence, knowing we may never sail beyond, yet still comforted by the wonder that such a place exists. And so, when you hear of event horizons, think not of destruction but of thresholds. Think of the quiet line where space folds too steeply, where time itself is pulled into a deeper current. Think of it as a horizon you can approach but never truly cross, unless you are ready to leave behind everything familiar. It is the edge of nothing, and yet in that nothing lies everything we still hope to understand. To understand black holes, you must first let go of the idea that space and time are fixed, rigid backgrounds against which the universe plays out. Einstein taught us that space and time are not separate, but threads woven into a single fabric called space-time, a fabric that can bend, stretch, and curve under the weight of mass and energy. Black holes are not merely objects within this fabric. They are places where it folds to an extreme, where geometry itself is drawn into impossible shapes. This is the 26th truth. Black holes do not just exist in space. They reshape space. They warp the arena itself, bending light, slowing clocks, and rewriting the path of every traveler that dares to approach. Imagine light, the purest traveler in the cosmos, racing in straight lines across the vacuum. Near a black hole, those straight lines are no longer straight. The 27th truth is that black holes bend light into arcs and circles, creating one of the most spectacular phenomena in the universe: gravitational lensing. A star that lies behind a black hole may appear doubled, ringed, or smeared into strange halos. A galaxy far beyond can seem to split apart and reassemble as its light is bent around the dark core. To astronomers, these distortions are not just tricks of perspective, but precious clues. They allow us to map the invisible, to weigh the black holes themselves, to see the unseen by the way it alters everything around it. In this way, black holes are both destroyers and artists, painting rings of fire from light that would otherwise pass unseen. The 28th truth is that time near a black hole is not the same as time far away. This is not an illusion, but a measurable fact, born from relativity. The stronger the gravity, the slower time flows. On Earth, clocks tick infinitesimally slower at sea level than on mountaintops because of the planet's gravity, though the difference is too small for most of us to notice. Near a black hole, the effect becomes profound. Minutes for one observer may stretch into centuries for another. To linger too close is to be pulled into a slower rhythm, trapped in a pocket of time that resists the universe's wider flow. In that sense, black holes are not only objects of mass, but also guardians of time, locking moments away behind their curvature. And yet, to fall into one is not the same as watching from afar. The 29th truth is that for an infalling traveler, the journey toward the singularity is smooth and merciless. You would not feel the horizon as you crossed it. From your own point of view, everything would continue, your path carrying you inward as if nothing extraordinary had happened. The stars outside would drift into distortion, their light bent into spirals, their colors red-shifting into deeper hues. You would feel the pull increase, stretching your body as gravity's grip grew uneven across its length. Scientists call this spaghettification, a word almost playful for something so final. To fall into a black hole is to be stretched thin across the fabric of space-time itself, until atoms are unstitched and your matter becomes part of the deeper collapse. From outside, the story is different. The 30th truth is that to distant eyes, you would never appear to cross the event horizon. You would hover there, frozen in time, your signals stretched into whispers, your image smeared and fading. The universe would seem to steal you slowly, never quite allowing you to vanish. But in truth, your fall would be complete. It is one of the paradoxes that black holes embody. From within, everything ends swiftly. From without, it is as though nothing ever quite concludes. They are places where perspectives split, where truth itself becomes relative. Gravitational lensing, time dilation, the strange duality of falling, all of these emerge not from imagination, but from the laws of relativity, the best map we have of how space-time behaves under weight. Black holes are its ultimate test, the places where equations stretch to their breaking point, where geometry collapses into singularities we do not yet understand. When you picture them, do not imagine voids. Picture instead the fabric of reality itself pulled into funnels, bending every path and distorting every clock. Black holes do not sit in space-time. They are space-time torn, stitched into new shapes by their own impossible density. To think of this is not to court fear but wonder. The universe allows such extremes, and yet we are able to glimpse them, measure them, and even use them as lenses to see farther into the cosmos. What begins as destruction becomes revelation. What feels like an ending reveals new perspectives. Black holes bend not only the paths of stars and light, but also the arc of human curiosity, drawing us again and again to their dark edges, eager to understand what lies beyond the torn horizon. And though we may never pass through and return, we are forever changed by knowing they exist, by imagining their pull, by drifting in thought toward the silent centers where space and time themselves give way. Black holes are often described as invisible, but invisibility does not mean absence. You cannot look through a telescope and simply spot one glowing against the sky, because by definition, they allow no light to escape. And yet their presence is as certain as the air you breathe, or the gravity that holds you to the earth. The 31st truth is that we know black holes exist because of the way they affect the things around them. They are not seen directly but traced by influence, like wind made visible only when it ripples the surface of water or bends the branches of trees. In the darkness where they hide, the universe leaves quiet fingerprints, and by studying those traces, astronomers have pieced together a portrait of the unseen. One of the most compelling signs comes from systems called X-ray binaries. These are pairs of stars, where one has collapsed into a black hole, while the other remains bright and luminous. Gas flows from the living star toward the black hole, spiraling in faster and faster until it forms a hot disk. That disk shines not in visible light but in X-rays, which can pass through interstellar dust and reach detectors orbiting high above Earth's atmosphere. The 32nd truth is that these X-ray flashes are beacons, markers of black holes silently feeding. By tracking the pattern and intensity of these emissions, astronomers can measure the mass of the hidden partner and confirm that nothing else but a black hole could account for such behavior. It is a reminder that even silence is not absolute. In the right spectrum, the unseen shouts. Another line of evidence comes from the wobble of stars. Gravity binds every object into motion, and when a black hole pulls on a nearby star, the star's path betrays the invisible weight beside it. The 33rd truth is that we can weigh the unseen by watching the seen. Astronomers point their instruments toward clusters, where stars dart and circle in curious loops. By tracing their orbits, by timing their accelerations, they can calculate the mass of whatever is tugging at them. In the center of our own galaxy, stars whirl around an empty point, completing tight, fast orbits in ways that make sense only if a supermassive black hole, Sagittarius A, is anchored there. To the eye it is nothing, but to mathematics it is millions of suns compressed into silence. Then there are the jets. Some black holes, especially the giant ones at galactic centers, produce towering streams of matter and energy that shoot outward at near-light speeds. It may seem paradoxical. How can something that swallows light also create such luminous outbursts? The answer lies not inside the event horizon, but just outside it, where magnetic fields and spinning disks of gas can fling material away before it disappears. The 34th truth is that black holes announce themselves in opposites, by their ability to hide and by their ability to shine. These jets, stretching across thousands of light years, are like cosmic lighthouses, visible from unimaginable distances. They tell us not only that a black hole is there, but that it is active, shaping the galaxy around it. The final piece of this quiet evidence is subtler still. The 35th truth is that black holes leave their mark in gravitational waves, ripples in space-time itself that spread outward when two of them collide. In 2015, humanity detected such waves for the first time, not by light, but by the stretching and squeezing of space recorded in vast laser observatories. It was a direct handshake with the invisible, proof that black holes not only exist but meet, merge, and echo across the cosmos. Every detection since has been another whisper of confirmation, another signal from the dark. And so, while it is true that black holes cannot be photographed in ordinary ways, it is not true that they hide completely. We see them not in their violence, but in their influence. We see the way they feed from stars, the way they tug on orbits, the way they fire jets across intergalactic voids, the way they ripple the very fabric of space-time. Each of these is a thread of quiet evidence, woven together into certainty. You can rest in the knowledge that they are real, not as monsters in the dark, but as features of the universe that reveal themselves in signs patient and profound. It is comforting, in a way, that something so extreme cannot fully disappear. Even the most perfect trap for light leaves behind echoes for us to follow. It means that the universe has balance, invisibility paired with trace, silence paired with signal, darkness paired with glow. As you drift into thought, imagine the stars dancing in orbits pulled by unseen partners. Imagine the invisible cords of gravity weaving patterns across the sky. The black holes themselves may be hidden, but their choreography is written everywhere, in wobbles and waves, in arcs of light and streams of fire. You live in a universe where even the unseen leaves footprints, and all you need to do is look carefully enough to find them. When you imagine a black hole, you might picture only a dark sphere suspended in space, silent and absolute. But the truth is, stranger and more radiant. Around many black holes, matter does not simply fall in all at once. It swirls, hesitates, spirals in endless loops, colliding with itself as it circles the abyss. This storm of infall is called an accretion disk, and it is one of the brightest, most violent structures in the cosmos. The 36th truth is that black holes, though themselves invisible, often wear crowns of fire. Gas drawn in from nearby stars, or from clouds that wander too close, is stretched into a thin, glowing disk. In these rings, gravity becomes a sculptor, bending the path of matter into spirals that can last for millions of years before vanishing beyond the horizon. As matter whirls inward, it speeds up, compresses, and crashes into other streams of gas. Friction in this crowded spiral ignites energy, heating particles to millions of degrees. The 37th truth is that the material in an accretion disk can shine brighter than the stars that fed it. At such temperatures, atoms are stripped apart, radiation streams outward, and the black hole that cannot shine itself is surrounded by a furnace luminous enough to be seen across billions of light years. It is a paradoxical spectacle. the eater of light wearing a cloak of brilliance stitched together from the very things it consumes. The 38th truth is that quasars are the most extreme example of this process. These are black holes at the hearts of galaxies, consuming matter at such a furious rate that their accretion disks outshine every star in their host galaxies combined. A quasar is not a single star, nor even a cluster of stars, but a black hole dressed in a disk so bright it can be detected from across the observable universe. To look at one is to see a beacon from the young cosmos, because most quasars shone when galaxies were still forming billions of years ago. They are cosmic cannibals turned lanterns, feeding so greedily that they light up the dark. But not every disk is a steady glow. Some flicker and flare as if breathing, responding to sudden surges of material or to magnetic fields twisting like ropes. Jets may erupt from the poles, thin streams of plasma accelerated nearly to the speed of light, launched not from inside the black hole, but from the chaotic edges of the disk itself. The 39th truth is that these disks are not just ornaments. They are engines. They heat, they radiate, they hurl matter outward while pulling matter inward, balancing creation and destruction in a single loop of motion. They shape their galaxies by stirring gas, fueling starbursts, and clearing regions with their fierce winds. The black hole grows heavier, but the galaxy around it is changed forever. The 40th truth is that accretion disks teach us more about the physics of extremes than almost any other structure in space. By studying their glow in X-rays and ultraviolet light, astronomers learn how matter behaves when pushed near the speed of light, when squeezed to densities unimaginable on Earth, when heated to temperatures that melt the very bonds of atoms. In their light is encoded the story of turbulence, magnetism, and relativity working together. These disks are laboratories written across the sky, natural experiments unfolding on scales we can observe only from afar. It is easy to think of black holes as endlessly still, as if they wait in silence until something falls into them. But the reality is dynamic. Their disks churn like rivers of fire, spinning around invisible centers, crashing, flaring, radiating. They remind us that even the most voracious darkness is never simple. There is drama in the falling, and beauty in the spiral. When you close your eyes tonight, you might imagine yourself drifting above such a disk, watching matter whirl in ribbons of light, watching time and gravity twist the glow into shapes beyond comprehension. Black holes do not simply consume, they perform, and in their cannibalism, they paint some of the brightest strokes across the canvas of the universe. The story of a black hole always begins with a death, but not the quiet kind we might imagine when we think of endings. Stars, those ancient furnaces burning hydrogen into light, live long lives measured in millions or billions of years. Yet even they cannot last forever. Some fade gently into red embers, drifting off as white dwarfs that glow faintly for eons. Others end violently, in explosions so bright they can outshine entire galaxies. The 41st truth is that many black holes are born in the collapse of massive stars, when their fuel is gone and their balance is lost. Gravity, which has always been tugging inward, finally overwhelms the exhausted pressure of fusion. What was once steady brilliance turns inward, and the star caves in on itself. This collapse is not peaceful. The outer layers of the star slam against the suddenly contracting core, triggering a rebound that rips the star apart. The result is a supernova, a flash of power so immense that it scatters heavy elements into space, the very elements that will one day form planets, oceans, and the iron in your blood. For a few weeks, this one dying star can shine brighter than the billions of stars surrounding it. Yet while its outer layers scatter into the cosmos, its heart shrinks past all resistance. The matter collapses so completely that no known force can halt it. At that moment, a black hole is born, silent at the center of the blast, a dark seed left behind by a stellar death cry. The 42nd truth is that not every massive star dies with a bang. Some collapse directly, skipping the brilliance of a supernova altogether. When a star is heavy enough, its core can fold inwards in a single motion, swallowing itself before the outer layers have a chance to explode. In these cases, the star appears to vanish, as if extinguished. To distant observers, it may look like a candle snuffed out without a trace, light ending with no finale. This direct collapse is quieter, but no less final. It leaves behind the same remnant, a region where gravity has grown so deep that nothing can climb free. Then there are the most extreme deaths, ones that radiate not just light, but the most energetic form of light we know, gamma rays. The 43rd truth is that some collapsing stars produce gamma ray bursts, the most powerful explosions in the universe. These bursts, lasting only seconds or minutes, release more energy than our sun will emit in its entire lifetime. They are thought to occur when the collapsing core funnels jets of matter outward at nearly the speed of light, piercing through the star and blasting into space. For a brief instant, the cosmos is pierced with a flare of invisible fire, detectable from billions of light years away. If such a burst were to occur close to Earth, it could sterilize the planet. Though fortunately, they are rare and mostly distant. Black holes are often the silent engines behind these outbursts, forming as the jets erupt and then sealing themselves away in shadow. The 44th truth is that black hole births are not just destructive, they are also creative. In the collapse of a star, heavy elements are forged and flung into the interstellar medium. Carbon, oxygen, calcium, gold. All of these are created in the violence of stellar death and scattered across the galaxy. Black holes emerge from these events, but so do the building blocks of life. Every cell in your body carries the signature of stars that once exploded, that collapsed, that gave their substance to the universe even as they fell silent. In this way, the creation of black holes is tied to the creation of us. Their darkness is written into our blood and bones. The 45th truth is that the universe is filled with ghosts of these violent births. Black holes wander the galaxy, invisible, remnants of stars that died long before humans walked the earth. Some are solitary, drifting through space with no companion. Others remain bound to stars, tugging at them, feeding slowly, or bending their light in invisible ways. Each is a silent reminder of a death long past. When we study the sky, what we see is light, but what we infer, again and again, are the shadows where light has ended. To know a black hole is to know the story of endings, collapses, and transformations too fierce to imagine. A black hole's beginning is not gentle. It is born in pressure and heat, in collapse and eruption, in silence and in fire. The universe writes its darkest structures with the brightest pens. Supernovae blazing across galaxies, gamma rays slicing through space, stars vanishing without farewell. The story of every black hole is a story of something too massive to last, something that fell inward when its flame was gone. Tonight, as you drift into rest, picture a star collapsing, its light scattering into the cosmos, its heart folding inward, its glow becoming memory. What remains is not absence but gravity itself, a dark center around which the universe will continue to turn. In the quiet of the universe, there are events so immense that they do not merely shine with light or blaze with fire. They shake the very fabric of reality. Black holes, usually so hidden, announce themselves most clearly not through sight but through soundless tremors in space-time itself. When two of them spiral together and merge, their union sends ripples outward, stretching and compressing the universe in delicate waves that race across billions of light years. The 46th truth is that black holes can be heard, not with our ears, but with instruments so sensitive they can detect a movement smaller than a fraction of a proton. These are gravitational waves, and they are the echoes of cosmic collisions, whispers from the dark. The 47th truth is that humanity first detected these waves only recently, in 2015, through the LIGO observatories in the United States. Long arms of laser light measured minuscule distortions as a pair of stellar mass black holes merged more than 1 billion light-years away. The signal was faint, lasting less than a second, but it matched predictions from Einstein's theory of general relativity made a century earlier. It was as if the universe itself exhaled, and for the first time, we felt it. Since then, dozens of such events have been recorded, each one marking the death dance of black holes as they collide and fuse into a larger whole. The 48th truth is that these mergers are both violent and strangely elegant. As the black holes spiral closer, they accelerate, moving at nearly the speed of light, their immense gravity warping time and space around them. They lose energy not through light but through waves of pure space-time, carrying away momentum, slowing their orbit, drawing them together. When they finally collide, they do not crash like solid bodies. Instead, they melt into each other, their horizons merging seamlessly into a new singularity, larger and heavier than before. In that instant, a fraction of their combined mass is transformed into gravitational waves, radiating outward in all directions like ripples in a pond, except the pond is the universe, and the ripples travel endlessly. The 49th truth is that these waves tell us stories we could never learn by light alone. Each signal carries information about the black holes that made it, their masses, their spins, the way they circled one another before they fell. Some mergers involve black holes a few times the mass of the Sun. Others, more recently detected, reveal black holes dozens of times heavier. By collecting these echoes, astronomers are beginning to map the hidden population of black holes in the universe. Creatures too dark to see directly, but too restless to stay silent. Each detection adds another note to a cosmic symphony that has been playing for billions of years, inaudible until now. The 50th truth is that gravitational waves are not just signals of black holes, but proof that space-time itself is flexible, stretchable, alive with motion. Imagine lying in a still pool, the water calm, the surface flat. Then, far away, a stone is dropped. The ripples eventually reach you, passing through your body, gentle and almost unnoticeable. That is what these waves are, ripples in the fabric of sleep, faint distortions passing through us even now, bending space ever so slightly as you rest. They move through everything, through the earth, through the walls around you, through your very atoms. You cannot feel them, yet they are there. Steady reminders that somewhere in the dark, two black holes once embraced and became one. There is something comforting in this thought. These events are unimaginably distant, unfolding in galaxies we may never see, but their effects arrive here, soft and silent, touching us all the same. The universe is not still. It is trembling with memory, humming with the faint vibrations of collisions that happened long before we were born. When you listen closely, not with your ears, but with your imagination, you might picture those waves washing over you, like tides too gentle to stir the sand, carrying with them the echo of unions written in gravity. Tonight, as you drift into sleep, the cosmos is still sending its ripples, quiet confirmations that even the darkest places are never entirely silent. Not every black hole may come from the death of a star. Some theories suggest that long before galaxies formed, before the first suns ever lit the sky, the universe might have seeded itself with darkness. The 51st truth is that scientists have proposed the existence of primordial black holes, ancient objects born in the first fractions of a second after the Big Bang. In that era, the cosmos was not smooth and even, but filled with fluctuations in density. Some of those ripples may have been so extreme that pockets of matter collapsed instantly, forming black holes smaller than any we know today. If they exist, they are relics older than galaxies, older than stars, older than almost everything we can see. They would drift through the universe like fossils from a time when physics itself was still settling into its laws. The 52nd truth is that black holes do not need to be massive giants. In theory, they could be as small as mountains, or even atoms. These hypothetical objects are sometimes called microscopic black holes. A black hole the size of a pebble could weigh as much as a planet, its gravity compressed into something you could hold in your hand if it were not for the fact that touching it would mean instant destruction. None have been detected, but the mathematics of relativity does not forbid them. In fact, some physicists think that particle accelerators, which recreate conditions close to the birth of the universe, might reveal signs of such exotic objects. If discovered, they would open a doorway into new realms of physics, places where quantum mechanics and gravity meet directly. The 53rd truth is that these stranger theories are not just playful imagination, but serious attempts to answer real mysteries. One of the largest mysteries in science is dark matter, the invisible substance that outweighs all the stars, planets, and gas combined, yet does not shine or interact with light. We know it is there because galaxies rotate faster than their visible matter should allow. The question is, what is it made of? Some researchers suggest that primordial black holes, tiny and numerous, could be part of the answer. Billions of them could drift through the universe, unseen but felt, their combined weight explaining the missing mass. If true, then black holes would not only sculpt galaxies, they would also make up much of the hidden architecture of the cosmos. The 54th truth is that the search for these possibilities is ongoing, and though no evidence has yet been found, the silence itself teaches us. Astronomers have looked for the telltale signs of tiny black holes passing in front of stars, briefly magnifying their light through gravitational lensing. They have studied the radiation that small black holes would emit if they slowly evaporated through a process called Hawking radiation. So far, the sky remains quiet, but quiet does not mean empty. It may simply mean that if these objects exist, they are rare or subtle or waiting to be noticed by instruments not yet built. Science lives as much in unanswered questions as in confirmed discoveries, and the absence of proof becomes part of the story. The 55th truth is that stranger theories remind us of the humility required to face the universe. Black holes, which once seemed like mathematical curiosities, turned out to be real, abundant, and central to cosmic evolution. Perhaps primordial black holes, or microscopic ones, or links to dark matter, will one day be confirmed too. Or perhaps they will remain in the realm of speculation, guiding us toward deeper understanding even if they are never found. Either way, their possibility stretches the imagination and deepens our sense of wonder. For now, we live with the mystery, drifting in a universe that may carry shadows older than stars, hidden companions as small as dust yet heavy as worlds, dark particles of gravity itself, moving unseen through the spaces between galaxies. And as you close your eyes, you can imagine them scattered like ancient seeds across the cosmos, quiet, patient, and perhaps part of the hidden skeleton of everything. Imagine lying on your back beneath the stars, watching the second hand of a clock tick smoothly along, steady and familiar. That rhythm feels absolute, unchanging, something you could set your life by. But near a black hole, time itself betrays this certainty. The 56th truth is that clocks run slower in the presence of extreme gravity, and no place bends the rhythm of time more dramatically than the edge of a black hole. To an outside observer, as you drift toward the event horizon, your moments stretch longer and longer. Your clock ticks more slowly. Your heartbeat lags behind the universe around you. To those who watch from afar, you would never quite cross that horizon. You would appear to freeze just before it, dimming and fading as your light is stretched into invisibility. Yet from your own perspective, time feels unchanged. You pass the threshold without pause, while the universe beyond you races forward into the future. The 57th truth is that this slowing of time is not an illusion, but a fundamental feature of space-time. Einstein's relativity revealed that gravity is not a force pulling downward in the ordinary sense, but a bending of space and time themselves. Near Earth, the effect is subtle. Astronauts orbiting above us age a little faster than we do, their clocks ticking ahead by fractions of a second. Near a black hole, the distortion is profound. Time becomes a pliable fabric, stretched so thin at the horizon that its flow nearly halts when viewed from outside. The black hole does not just capture light, it captures the very passage of existence. To approach it is to approach a boundary where meaning itself shifts, where before and after grow uncertain. The 58th truth is that gravity also stretches matter, not just moments. The pull of a black hole increases sharply with distance, tugging harder on your feet than your head if you were falling in upright. This difference in pull creates a process known, somewhat playfully, as spaghettification. It is a gentle word for a merciless effect. As you fall closer, your body would elongate into thin strands, atoms drawn apart, molecules unzipped, all stretched in the same inexorable direction toward the center. To imagine it without fear, you might picture a thread of light unraveling across the darkness, fibers lengthening until they blur into nothingness. In the silence of thought, it becomes less a violent tearing and more a dissolving, like paint brushed across a wide canvas of space. The 59th truth is that spaghettification depends on scale. A small black hole, only a few times the mass of our sun, would shred you long before you reach the horizon. Its gravity changes so quickly over small distances that nothing could resist the stretching. But around a supermassive black hole, millions of times heavier, the gradient is gentler. You could, in theory, cross the horizon without immediate destruction, passing into the dark interior while still intact. Your journey would end eventually at the singularity, where all paths converge, but for a while, you might continue inward in silence, a traveler into realms no one has ever seen. It is a reminder that black holes are not all alike. Their violent scales with their size, and in their enormity, some allow a strange kind of mercy, granting more time even as they take it away. The 60th truth is that when we speak of these effects, we are not only describing physics but reshaping our sense of reality. To imagine time slowing until it stops, to picture matter stretched into infinite thinness, is to confront the edges of understanding. Yet it is also to find a kind of meditative stillness. Clocks whisper slower at the horizon, each tick lingering longer, as if inviting rest. Threads of being stretch across the silence, unraveling into finer and finer strands until they merge with the dark. What seems terrifying when said quickly becomes strangely peaceful when felt in rhythm with the cosmos. The black hole is not only a maw of destruction, it is also a place where time becomes fluid, where the boundaries of self and space blur into a continuum wider than comprehension. As you drift off tonight, you might imagine your own moments slowing, your thoughts stretching thin like threads of starlight across a calm horizon carried gently toward rest. There was a time when scientists believed that black holes were eternal, that once matter fell inside, it was sealed away forever, locked in an endless prison of gravity. The 61st truth is that Stephen Hawking changed that view. In the 1970s, by uniting quantum mechanics with the curved geometry of relativity, he discovered that black holes are not entirely black. They glow faintly, with a radiation born not from their interiors but from the strange quantum behavior of empty space around them. This glow is now called Hawking radiation. It is not bright, not blazing, but subtle, like the faintest ember in the deepest dark. According to his equations, no black hole can last forever. Even the largest giants are slowly leaking themselves into nothingness. The 62nd truth is that Hawking radiation arises from the uncertainty of the vacuum itself. What we call empty space is never truly empty. Instead, it seethes with virtual particles flickering in and out of existence, pairs of opposites appearing for an instant and vanishing again. Near the edge of a black hole, these pairs can be torn apart by gravity. one particle may fall inward while the other escapes, becoming real. To an outside observer, it looks as though the black hole is radiating. The escaping particle carries away energy, and over time that energy must come from the black hole's mass itself. Slowly, invisibly, it shrinks, like an ice cube melting in space too vast to notice. The 63rd truth is that this process is so slow that for most black holes it hardly matters. A stellar mass black hole, heavier than our sun, would take longer than the current age of the universe to evaporate. A supermassive black hole, like the one at the center of our galaxy, would take a time so vast it dwarfs imagination. Trillions upon trillions of years, epochs beyond the lifetime of stars, galaxies, and even the atoms we know. For now, they are as permanent as mountains compared to our fleeting lives. And yet, the idea that they will one day fade reshapes our sense of eternity. What we once thought of as everlasting turns out to be mortal, dissolving not in fire or violence, but in the faintest breath of radiation. The 64th truth is that Hawking's discovery carried implications far beyond physics. It bridged worlds. On one side, relativity describes the smooth flow of space and time, the grand sweep of gravity. On the other, quantum theory rules the smallest scales, where particles pop in and out of being. These two realms rarely speak the same language, but at the edge of a black hole, they meet. Hawking radiation became the first glimpse of a possible bridge between them. It showed that even at the horizon, nature cannot be captured by only one theory. The greatest mysteries may lie in the places where opposites touch, where smoothness meets chaos, where certainty fades into probability. The 65th truth is that in the far future, when stars have burned out and galaxies have drifted apart, the universe may still hold its last glow in these whispers of radiation. Black holes, once the ultimate consumers, would become the final beacons, radiating away into silence. Slowly, imperceptibly, they would shrink to nothing, leaving only faint ripples of energy behind. In this vision, the cosmos does not end with a sudden collapse or a burst of light, but with a long, quiet dimming. Even the darkest giants glow faintly in theory, and that faint glow might be the last light the universe ever knows. And so, as you rest, you can think of Hawking's whisper not as a threat, but as a reminder that nothing is truly eternal. Not stars, not galaxies, not even black holes. The universe itself is in motion, flowing toward futures stranger than we can see. But within that motion, there is a kind of peace. Darkness breathes softly, energy drifts outward, and even the heaviest hearts release themselves, one quiet particle at a time. Galaxies may appear to us as serene islands of light, billions of stars glowing together in quiet swirls and arcs. But beneath that calm is a hidden architect. The 66th truth is that black holes, especially the supermassive ones at galactic centers, do not simply sit as passive anchors. They shape the evolution of their galaxies in ways we are only beginning to understand. The gravity of these giants holds stars in orbit, keeps the rhythm of rotation steady, and sets the scale of the luminous city of suns around them. Yet their influence extends far beyond simple gravity. They act like gardeners of the cosmos, pruning growth, stirring material, and sometimes igniting new creation through their restless power. When matter falls toward a black hole, it does not always vanish quietly. The 67th truth is that some of it is redirected, accelerated, and cast back outward as immense jets of energy and particles. These jets can stretch across thousands of light years, thin beams of matter moving at nearly the speed of light. Though born from destruction, they bring order, carving out cavities in surrounding gas, heating interstellar clouds, and limiting how quickly stars can form. Without this feedback, galaxies might collapse into overly dense knots, burning through their gas too quickly, leaving little room for new generations of suns. Instead, black holes regulate, slowing the pace, ensuring that galaxies grow not all at once, but over billions of years, in chapters and cycles. The 68th truth is that entire galactic shapes are tied to these hidden forces. Observations show that galaxies with the most active black holes, quasars blazing at their centers, jets stretching like cosmic lances, often have fewer new stars than expected. The energy streaming outward heats and pushes away the very gas that would otherwise cool and collapse into stellar nurseries. It is as though the black hole, while feeding, also decides when its galaxy may rest from birth, giving the interstellar medium time to settle before beginning again. In this way, black holes are sculptors, chiseling their environments not by touch, but by radiance and force. The 69th truth is that black holes may determine the very size of galaxies themselves. The mass of a central black hole is not random. It correlates strongly with the mass of its host galaxy's bulge. This relationship suggests a feedback loop. As the galaxy grows, so does the black hole. And as the black hole grows, it controls how much more the galaxy can expand. Too much energy flung outward, and star formation dwindles. Too little, and the galaxy might collapse under its own weight. In this balance, a hidden hand guides the architecture of the universe. Galaxies are not just shaped by the stars we see, but by the invisible heart we cannot. The 70th truth is that without black holes, galaxies would look profoundly different. The spiral arms, the steady star formation, the long lifespans of stellar populations. These may all owe themselves in part to the quiet regulation of central giants. Black holes are not only destroyers but caretakers, regulating growth like gardeners who prune branches to let the tree breathe. They are both sculptors and stewards, violent in method but gentle in outcome, ensuring that galaxies evolve in harmony over immense stretches of time. So when you look at the sky and see the Milky Way stretched like a river of light, remember that its structure, its rhythm, even its survival, is tied to the silent conductor at its center. The galaxy blooms and withers, forms stars and rests, not only because of the stars within it, but because of the black hole that stirs, regulates, and sculpts it from the core. And as you drift towards sleep, you can imagine these gardeners at work across the cosmos, not with shears or hands, but with jets of fire, currents of energy, and the invisible pull of gravity, tending the galaxies like vast living gardens under an endless night. In the long, quiet stretches of night, when the stars seem to whisper rather than shine, our minds drift most easily into the realm of what might be rather than what is. Black holes themselves already feel like impossibilities made real, regions where gravity pulls so fiercely that light itself cannot flee. But there are ideas stranger still. The 71st truth is that physics allows for the possibility of naked singularities, though none have ever been found. A singularity is the hidden heart of a black hole, the point where density becomes infinite and our equations break down. Usually, this core is cloaked safely behind an event horizon, concealed by a veil that prevents its secrets from escaping. But in the mathematics of relativity, there are solutions that allow singularities to stand bare, with no horizon to hide them. If such objects exist, they would expose the raw edge of space-time, a place where the laws we rely on collapse. It would be a cosmic secret, not just hidden, but unveiled, daring us to stare into the unexplainable. The 72nd truth is that black holes may not only consume but also connect. Some theories suggest that their extreme warping of space-time could form tunnels, passages linking distant points in the universe. These are called wormholes, and while they remain speculative, they stir the imagination. A wormhole might be traversable in theory, a shortcut between galaxies, a hidden bridge from one region of reality to another. Yet even in the gentlest equations, such stability would require exotic forms of matter, substances with negative energy densities that we do not yet know how to create. Without them, the tunnel collapses faster than light could cross. Still, the thought lingers like a dream. black holes as doors, not just prisons, as invitations to wander the wider universe in ways that starlight cannot. The 73rd truth is that if black holes can exist, their opposites might as well. These are called white holes, theoretical objects that cannot be entered from the outside, but which spill matter and energy outward without ever drawing anything in. Unlike black holes, which capture and hold, a white hole would repel and release, a fountain instead of a drain. In mathematics, they appear naturally as mirror images of black hole solutions, yet we have never glimpsed one in the sky. Some speculate they may be tied to the birth of the universe itself, sudden eruptions of energy that left only expansion in their wake. In their imagined glow, one can almost sense a balance, as if the cosmos itself prefers opposites, pairing abyss with eruption, silence with voice. The 74th truth is that in these extreme ideas, the boundaries between science and speculation blur in fascinating ways. Naked singularities challenge the cosmic censorship hypothesis, which claims that nature abhors exposed infinities and hides them behind horizons. Wormholes remind us that space-time is not rigid but flexible, curved and bent in ways that may permit passages we cannot yet comprehend. White holes call into question the direction of time itself, forcing us to wonder whether beginnings and endings might not be so different after all. Each possibility exists on the far edge of our understanding, dreamlike, elusive, and shimmering, with a sense of almost. The 75th truth is that whether or not these entities exist in the universe we can see, they exist in the universe we can imagine. They remind us that black holes are not just astronomical objects, but also philosophical thresholds. They open questions about the nature of reality, the possibility of shortcuts across vast gulfs, the symmetry of creation and destruction, the limits of what the human mind can hold. They stand as invitations to wonder, to dream beyond evidence, to accept that the universe is not bound by our need for simplicity. As you lie in the dark, picture these oddities not as hard equations on chalkboards, but as shimmering shapes on the horizon of thought. A naked singularity like a jewel uncovered, shining with dangerous brilliance. A wormhole like a tunnel carved through midnight, promising arrival in some far-off corner of starlight. A white hole as a radiant fountain, pouring creation into silence. None of them proven, all of them possible. They are the myths of modern science, woven not from superstition but from mathematics and curiosity, as fragile and as stirring as dreams that come just before sleep. When people first hear about black holes, the imagination often leaps to fear. A cosmic monster, hungry and unstoppable, drifting silently through space and waiting to devour whatever crosses its path. But the 76th truth is this: Earth is not in danger. The nearest known black hole lies thousands of light years away, so distant that even moving at unimaginable speeds, it could never suddenly appear in our skies. Black holes do not roam with intent or malice. They are not hunters, only heavy relics of dying stars, minding their orbits like any other celestial body. The universe is vast beyond comprehension, and in that vastness, our little planet rests quietly, untouched by the gravity wells that haunt the minds of storytellers. The 77th truth is that black holes can drift through interstellar space, unanchored to any star or system. Some are born in violent supernova explosions that give them a kick, a gravitational shove that sends them sailing across the galaxy. Others may be ejected during interactions with other massive bodies, cast off into the dark, like stones skipped across a cosmic sea. These wandering black holes are invisible unless they pass near matter, but astronomers believe there could be hundreds of millions of them spread throughout the Milky Way. Yet even if they drift, the odds of one ever passing close to Earth are infinitesimal. Space is not crowded. It is a great ocean, mostly empty, where stars and planets are like islands separated by vast gulfs. To cross paths with a black hole would require an almost impossible alignment. The 78th truth is that astronomers search for these hidden wanderers, not because they pose danger, but because they reveal the hidden architecture of the galaxy. When a rogue black hole moves past a field of stars, its gravity bends the light in subtle ways, a phenomenon called microlensing. The background star brightens as if by magic, a silent signature of a dark traveler moving unseen between us and the far horizon. Detecting these fleeting glimmers lets scientists estimate how many unseen black holes are out there, drifting quietly through the dark. The picture that emerges is not one of chaos or threat, but of calm persistence, remnants of ancient stars following their lonely paths. The 79th truth is that the black holes we know best, like Sagittarius A, at the center of our galaxy, do not fling their influence outward unchecked. Their gravity, while immense near their hearts, fades with distance in the same way any star's pull does. If the sun were magically replaced by a black hole of equal mass, Earth would continue to orbit it as before, untouched by sudden collapse or devouring. We would lose sunlight, warmth, and life, but not our orbit. Black holes do not reach across the galaxy to snatch at worlds. They shape their surroundings, yes, but they obey the same rules of gravity as every other mass in the cosmos. The 80th truth is that our place in the galaxy is, in its own way, a gift of safety. We orbit not in the crowded galactic core, where stars jostle close and black holes may lurk in abundance, but in a quiet suburb, a spiral arm less dense and less chaotic. Here the stars are more widely spaced, the cataclysms more distant, the risks lessened by sheer distance. We are tucked into a stable orbit around a steady sun, in a neighborhood where life had the time and peace to evolve without constant interruption. It is not luck alone, but the natural quiet of our location that shields us from cosmic hazards. And so, when you think of black holes, do not think of them as looming predators hovering just beyond our sky. Think of them instead as reminders of what the universe can create and what it can contain. They are far away, silent, and bound by laws that keep them from intruding into our daily lives. We may imagine them drifting through interstellar seas, but we know that our corner is calm. We are safe, surrounded not by threat but by distance, not by chaos but by quiet. Black holes exist, yes, but we live in a pocket of peace, where the night sky is filled with starlight instead of shadows. And that, too, is part of their story. That they inspire awe not because they are near, but because they are far, whispering from the edges of what we can see, while we rest in the gentle cradle of a galaxy vast enough to keep us safe. There are moments in science that feel like standing at the edge of a vast ocean, holding a lantern toward the dark, and suddenly realizing that the waves are moving in response. The study of black holes has always lived at that boundary, in the space between the invisible and the imaginable, where equations stretch their arms toward mysteries no telescope could touch. For decades, astronomers worked in faith, tracing the pull of stars, the glow of jets, the flicker of X-rays, all the while knowing the true heart of a black hole could never be seen. And yet, the 81st truth is that in April of 2019, humanity did the impossible. We took the first direct image of a black hole, a faint glowing ring around a shadow in the galaxy Made 7, 55 million light-years away, brought into focus what had once been only theory. It was not sharp like a photograph of the moon, but soft, glowing, blurred at the edges, like firelight seen through smoke. It was, in every sense, a portrait of the unseeable. The 82nd truth is that this image was not captured by a single telescope, but by a planet-wide collaboration called the Event Horizon Telescope. No single observatory on Earth could ever achieve the resolution required to glimpse the edge of a black hole. But together, 8 radio telescopes spread across the globe, from Chile to Hawaii, from Spain to the South Pole. They formed one virtual eye the size of Earth itself. This technique, called very long baseline interferometry, stitched together data from across the planet, aligning atomic clocks to within a billionth of a second, gathering petabytes of information carried on hard drives flown by airplane. It was science and choreography at once, a ballet of precision stretching across continents. The 83rd truth is that the image revealed exactly what Einstein's theory of general relativity predicted. The glowing ring of light was not the black hole itself, but the heated matter spiraling at near-light speeds just beyond its event horizon. Light bent around the gravity well, piling up into a halo that encircled a central shadow. The size of that shadow matched predictions perfectly, a validation of physics born more than a century earlier. Yet it was not just confirmation, it was revelation. For the first time, we saw with our eyes what equations had whispered, and it was exactly, beautifully true. The 84th truth is that this was only the beginning. In 2022, the Event Horizon Telescope team unveiled another image, this time of Sagittarius A, the supermassive black hole at the center of our own Milky Way. Smaller than Mate 7's giant, but much closer, just 26,000 light-years away. It proved far more difficult to photograph. The hot gas swirling around it changed in minutes, like trying to photograph a candle flame that flickers and reshapes itself constantly. Yet after years of careful computation, the image emerged. Another blurred golden ring, another shadow framed by fire. To see it was to look into the quiet heart of our galaxy, the invisible conductor of its spiral dance. The 85th truth is that these images are not pictures in the way we usually mean the word. They are reconstructions built from radio waves, transformed by algorithms into visible form. In a way, they are paintings made with data, shadows painted with light. Every pixel carries the effort of thousands of scientists and years of work, yet what they reveal is not an artifact, but a reality. The shadow of the black hole is real, its ring of fire is real, and the dark heart at its center is more certain now than it has ever been. The 86th truth is that seeing a black hole was never guaranteed. For decades, skeptics doubted whether such an image was even possible. The scattering effects of interstellar gas, the faintness of the signals, the sheer precision required, all of these seemed insurmountable. Yet humanity has a way of pushing at the frontier until the frontier yields. By building global collaborations, pooling resources, and daring to attempt what seemed beyond reach, we expanded our sightline into the abyss. The universe, once silent on this matter, answered with a glow. The 87th truth is that these efforts have not ended. The Event Horizon Telescope continues to refine its techniques, planning to add more observatories, more wavelengths, and sharper resolution. Future images may capture the motion of matter around black holes in real time, showing us not just a still portrait, but a film of light orbiting the dark. We may one day witness the dynamics of a black hole feeding, the jets of energy erupting, or the shadows shifting as space-time itself ripples. Seeing these changes will not only confirm our theories but reveal details we have not yet imagined. The 88th truth is that black hole imaging does more than satisfy curiosity. It offers new ways to test the very fabric of physics. If relativity were wrong, if some other force shaped gravity at extreme scales, it would show itself here, at the edge of nothing. Every new observation is a question posed to the universe. Do the equations still hold? So far they do. But with every finer glimpse, we press harder, searching for cracks in our understanding that may lead to deeper truths. The 89th truth is that these achievements belong not to one nation or one observatory, but to humanity as a whole. The first image of a black hole was not an American discovery or a European discovery or an Asian discovery. It was Earth's discovery. Scientists across dozens of countries worked together, united not by borders but by the shared wonder of seeing what was once invisible. The universe does not care about our divisions. It simply waits for us to look deeply enough. And the 90th truth is that, perhaps for the first time, we have truly begun to see black holes not as abstractions but as places. They are not only equations or theories, but real objects, real horizons, real shadows against the fire of creation. To glimpse them is to expand the realm of what human eyes can know, to stretch our perception into the domain of the infinite. It is, in the truest sense, seeing the unseeable. And as you rest tonight, you carry with you that quiet miracle, that we live in a time when the universe has begun to reveal its darkest hearts, and we have learned how to paint them with light. There comes a time in every story where the telling must soften, where facts become reflections and knowledge folds gently into wonder. Black holes, those most secretive of cosmic phenomena, have guided us through 90 truths already, each one adding another brushstroke to the portrait of the dark. Tonight we gather the last 10 together, not as sharp revelations, but as a constellation of thought, a way of seeing the whole picture as it glimmers in the quiet of your imagination. The 91st truth is that black holes are not merely destroyers. They are preservers too, guardians of balance. By limiting how galaxies grow, by regulating the birth of stars, they keep the cosmos from burning too quickly. They are surgeons with the roughest of tools, violent in their methods, yet subtle in their outcomes, shaping creation even as they consume. The 92nd truth is that the material that falls toward a black hole does not vanish silently. It blazes, it radiates, it paints arcs of light across the universe. In this way, black holes give as much as they take, announcing themselves not with their own glow, but with the brilliance of matter on its final descent. They are lanterns born of endings, reminders that even collapse can create beauty. To watch their light is to watch transformation itself, death unraveling into illumination. The 93rd truth is that black holes have taught us humility. They are places where our equations falter, where relativity and quantum mechanics still refuse to blend. They mark the boundaries of human knowledge, edges where we must whisper instead of proclaim. To contemplate them is to acknowledge how much we do not know, how many mysteries remain hidden in their silence. And yet it is precisely at those edges that discovery waits. Black holes remind us that ignorance is not failure, but invitation. The 94th truth is that black holes are storytellers of time. In their presence, clocks slow, moments stretch, futures race ahead. They show us that time is not absolute but elastic, bending to the will of gravity. To imagine yourself near one is to imagine a life lived in a different tempo, where centuries pass outside while your seconds still flow. They hold within them the strange reminder that even time is not fixed, but a fabric that can fold and stretch in ways our everyday lives cannot reveal. The 95th truth is that black holes are not unique to the distant cosmos alone. They belong to our home galaxy too, to the Milky Way you see stretched above you on a clear night. At its center, Sagittarius A waits in silence, 4 million suns compressed into a region smaller than the orbit of Mercury. It anchors everything around it, including the stars that circle above your head tonight. To look at the sky is to look at a dance orchestrated by a conductor you cannot see, a reminder that we are already part of their story, whether we notice or not. The 96th truth is that black holes may connect us to the very origin and fate of the universe. Some theories suggest they could seed new universes in their depths, or that the Big Bang itself may have sprung from conditions not unlike those inside a black hole. These are speculations, yes, but they reflect a deeper truth. Black holes are not just oddities scattered across space. They may be woven into the very structure of reality, both womb and grave, both boundary and passage. The 97th truth is that we will never stop searching for them. With new telescopes, sharper instruments, and deeper surveys, we will continue to map their numbers, measure their masses, and capture their shadows. Each new discovery folds them more tightly into the story of the cosmos. What once seemed exotic is now essential. Black holes are not rare monsters. They are common features of galaxies, companions of stars, neighbors of light. To understand the universe means to understand them. The 98th truth is that, even in their silence, they unite us. The first images of black holes, the detections of gravitational waves, the great collaborations of scientists around the world. These were achievements of humanity together. The universe gave us puzzles too large for any one person or one nation, and we answered as a species, combining minds and tools across the globe. In that way, black holes teach us not only about physics, but about ourselves. The 99th truth is that black holes, for all their strangeness, are not separate from us. The heavy elements scattered by the stars that birthed them are the same elements in our bones and blood. The same gravity that pulls stars into their orbits pulls your body gently toward the Earth. You are part of the same fabric of space-time, made of the same matter, subject to the same laws. When you think of black holes, do not think of something alien. Think of family, distant and extreme, but kin all the same. And the 100th truth is that as you rest beneath the stars tonight, you are safe in a quiet corner of the galaxy. Black holes drift far away, shaping galaxies, sculpting light, whispering through gravitational waves. But they do not threaten you here. You live under the same sky that holds them, in the same universe that forged them, carried by the same gravity that stirs them. You are part of this vast story, born from the same forces that bend light and slow time, sustained by the same balance that black holes preserve. So let your thoughts drift as galaxies drift. Let your breath fall into rhythm with the quiet turning of the Earth, and sleep in the knowledge that you belong to the same cosmos. You are shaped by the same forces, resting safely in the arms of gravity. Sleep well.